Okay, so I want to talk to you a little bit about the difference between vertical and horizontal parabolas. So y equals ax squared plus bx plus c is the standard form of a parabola, and it's a vertical parabola because it's y equals in terms of x. And just so you can recall, the vertex form would be y equals a times x minus h squared plus k. And the vertex being hk. The only thing that's kind of weird that you need to remember is that whatever's in parentheses here is going to be opposite. So if it's a -5, that means it's going to be a +5 as an h. If it's a +3, it means it's going to be a -3 as an h. You always need to remember that. The k value is not opposite. If it's a +3, it's 3. If it's a -5, it's -5. And this general will give you a vertical parabola, something that we're all familiar with. Making this a value negative reflects it over the x-axis, making it an upside-down vertical parabola. That's the general rules for vertical parabolas. Now, horizontal parabolas are going to follow the same exact rules with just a couple little hitches. It's x equals ay squared plus by plus c. How you will more likely see these types of parabolas are when the vertex is at 0, so it'll just be x equals ay squared. There's no h, there's no k, so it's at 0, 0. If the vertex isn't at 0, 0, you'll likely see it in vertex form, which is x equals ay squared. And it still is going to have an h and a k, but it's going to be slightly different. Instead, your minus k is on the inside and your plus h is on the outside. That's the only weird thing. The vertex is still hk. That's still your vertex. It's still hk. The difference is the h is out here. And again, what's outside the parentheses is not opposite. So if you had a +4, +4 would go there. If you had a -3, -3 would go there. The k is what's on the inside. And so it's opposite. So if it was -4, +4 would go there. If it was +4, then -4 would go there. That's really the only difference between the vertical and horizontal parabola. So if your a value is positive, you're going to get this positive looking parabola. It's just going to be pointing to the right. It's horizontal. Making this a value negative would flip it and make it point the other way. So that's just some general information. You are going to be expected to do both horizontal and vertical. Again, this is called vertical, and this is called horizontal, just so you can keep that straight. And so on Friday's lesson, we talked about, I'm sorry, I don't want to say on Friday's lesson, because you might watch this in a different semester. So in our most recent lesson, we did focus and directrix. And you need to be able to apply focus and directrix to both vertical and horizontal parabolas. So let me just recall the basic rules of the focus directrix. You need to find the focal length. Some books are going to represent this with a C, maybe some other letters. I use F because I think F and focal length go together pretty well. It doesn't really matter. The important thing is to know how to find it. The focal length is equal to 1/4 times that a value. And that's the a value that's here, and all of these, whether it's vertical or horizontal, it's that same a value. And so 1/4a. And because this is a reciprocal, you've got something equaling 1 over something. That means you could find your a value by taking 1/4 times the focal length. Again, you can see it with any letter. I just want you to remember that focal length is what goes there. I'm going to represent it with an F a lot. Other teachers might use a C. And so the next big piece of information, once you find the focal length, is to know that once you have your vertex, which we've established is hk, you're going to add to that vertex to get your focus. You're going to subtract from that vertex to get your directrix. With that comes some very helpful information that you need to remember. That way, if you added and subtracted incorrectly, it's a good way to self-check. Any parabola, whether it's vertical or whether it's horizontal, the focus, so you've got your vertex here. Let's point that out first. V for vertex. Your focus will always be in line with your vertex inside of the parabola. Always. Focus. Focus. And so if you add your focal length to your vertex incorrectly, it may not be on line with your vertex. Maybe it'll be over here, or it might not be inside your parabola. If your focus is down here, you did something wrong. Your focus has to be in line with the vertex inside the parabola. In line with vertex, and it has to be inside parabola. Your directrix, if I have the same thing going on here, is always a line, and it's always outside the parabola. So we'll use green. Your directrix is always a line, and it's always outside the parabola. Now, with horizontal parabolas, you'll notice your directrix is a vertical line. Vertical lines are x-equal lines. On a vertical parabola, you have a horizontal line. Horizontal lines are y-equals lines. So your directrix is always going to be x equals something or y equals something. And it's always going to be outside the parabola. And so lastly, it's important to know that to self-check and make sure you've done it correctly, your focus and your directrix have to be the same distance away from your vertex. That distance has to be the same, and it's always going to be that focal length that you find by doing 1 over 4a. Alright, so now that we've got kind of all the information, let's just do a couple practice problems. I'm going to do a few different ones here. So let's start with well, I'll let you decide which type it is. We'll go y equals 2x squared plus 3x plus 1. Yeah, I mean, I've already wrote it. We'll go with it. So the first thing we need to do is find the vertex of this parabola. That can be done by negative b over 2a, comma, plug it in. And so negative 3 over 2 times 2 is negative 3/4. That is my axis of symmetry. So if a problem asks for your axis of symmetry, you would say x equals negative 3/4. How do I know it's x equals negative 3/4? Let's just kind of roughly sketch this here. I know that this is a y equals, so it'll be a vertical parabola. I notice that my a value is positive, so it'll be right side up. And so I'm just going to sketch that. And my axis of symmetry, the middle of my parabola, is at negative 3/4. Well, that makes a vertical line. And remember, vertical lines are x equals something. And so x equals negative 3/4. That's my axis of symmetry. And so now my vertex has to fall on this line somewhere. And so that's why we plug it in. I probably won't make you do one this difficult without a calculator. So I'm going to go ahead and get a calculator. So if I put in parentheses negative 3/4 and I square it, I get 0.5625, and I multiply that by 2, I get 1.125 plus 3 times negative 3/4 is negative 2.25, and then I've got plus 1 at the end. So if we add all those together, plus, I get negative 0.125. If you're curious, as a fraction, that's negative 1/8. So my vertex is negative 3/4, comma, negative 1/8. So if I readjust my graph here, it's actually the vertex is gonna be a little lower, like that. Alright, now that I know my vertex, I want to find my focus and my directrix. And while we're at it, we'll even talk about the domain and range, because you are going to be asked to do that. So to find the focus and directrix, I need to know the focal length. Well, the focal length, remember, is 1 over 4a. Well, my a value is 2, so 1 over 4 times 2 is 1/8. So I'm going to add 1/8 to my vertex and subtract 1/8 from my vertex to get my focus and directrix respectively. And so a lot of people like to try to memorize this, but I say just do trial and error. So if I add negative 1/8 to the x value of my vertex, negative 3/4 plus 1/8, I get negative 5/8 as an x value. Well, if I look at that, if I go over negative 5/8, that's going to be right here. That's not going to be in line with my vertex, meaning that's wrong. So let's instead add it to the y value, which is in fact how you find the focus. You're going to add it to the y value in a vertical parabola. So if I add 1/8 to negative 8, my focus is negative 3/4, 0. And so my focus is in here. So I've got my vertex here. My focus is on the inside now, in line with my vertex. So that's great. Now directrix, we would subtract 1/8. Again, we want to make sure it's in line. And so we are going to take it from that 1/8. So negative 1/8 minus 1/8 is going to give us negative 1/4. So x equals negative 1/4. So if you are a person who likes to memorize stuff in a vertical parabola, you're always going to add and subtract from the y value of your vertex. And that's really it. That's all we need to do. We'll save domain and range for another video. So now let's do an example of a horizontal one. That way you have it. And let's say we have, I don't know, x equals, I want to give this a fraction, 1/8 y minus 2 squared plus 1. So the first thing we need to do is find the vertex. Well, do not use negative b over 2a here for two reasons. One, it's not in standard form, and two, that might not be necessarily how you do it with a horizontal parabola. So instead, we know this is in vertex form. We just need to find the h and the k. Well, remember, in a horizontal parabola, when your y is what is being squared, when your x is what is being set equal to, this represents your h value, and this represents the k value, remembering that it's always opposite. So our vertex in this case is going to be 1, 2. And it's a positive a value, so my parabola is going to be at 1, 2, and it's going to open this way. Okay, and so now what we have to do is find our focal length. That way we can find the focus and directrix. And remember, the focus better be in line with my vertex, and my directrix better be a vertical line, and they better be equidistant. So let's find the focal length. 1 over 4a equals our focal length. So 1 over 4 times 1/8. Okay, so I want, the reason I picked this one is you need to be able to do this without a calculator. So 4 over 1 times 1 over 8 is 4 over 8. So how do I do 1 divided by 4/8? Well, we can reduce that 4/8 fraction, 1 over 1/2. And when you divide, so 1 over 1 divided by 1/2. To divide fractions, you flip the second one and multiply it. So 1 over 1 multiplied by 2 over 1. My focal length is 2. So now I'm going to add 2 to this vertex to get the focus, and subtract 2 from the vertex to get the directrix. I'm trying to write an F up here, but there we go. And so again, instead of trying to memorize, let's try both of them. If I add this 2 to the y value like I did before, I would get the point 1, 4. Well, is that point inside of my parabola? No, so it can't be the focus. So instead, let's try adding it to the x value. And so we get the 0.32. Well, now it's on the inside of the parabola and it's on line with the vertex. And so we're going to take that same knowledge and subtract 2 from that to get to the directrix. And if we do that, we get -1, and it's a vertical line. So our directrix is x equals -1, and our and I just realized I messed up a horizontal line back on this page. It should be y equals. Hopefully someone caught that and they didn't have to have me go back and explain it. But I fixed it now. Sorry for the confusion. Vertical lines are x equals, so our directrix is x equals -1, and our focus is 3, 2. Alright, that's focus and directrix of both vertical and horizontal parabolas. I went a minute over what I like to go over. If you have any questions, leave a comment. Again, sorry for the mistake on the directrix. It should be y equals. Keep that in mind. Alright, have a good day.